Today, our group will present to you our data science project about smart cities prevention to homelessness in New York City. We have 8 main topics, starting with the first 3 topics will be explained by myself, Fajar Wijaya, and then the next 3 topics will be explained by Andrew Kusuma, and the last 2 topics will be explained by Iwan Darmawan. So, what is a smart city? Basically, it is a modern city that establishes the availability of resources to improve the life of citizens. New York City is one of the examples. It has been ranked highly and leading as a global city for 6 years straight. But sadly, with everything so smart, New York City has the second largest homeless population in the US. Therefore, we came up with a project to help on minimizing this homeless population problem. We want to know what is the most contributing factor to the number of homelessness in New York City. Based on qualitative analysis by Piat, the pathways for one person to become homeless are very complex and have many factors, such as domestic violence, increasing housing price, etc., as you can see in the slide as mentioned by them. So we propose a different approach by using quantitative study, a machine learning method, to explore what are the most significant factors that impact homelessness. There are some important roles in this project. First, we need data engineer to give us a proper data stream from many trusted sources into our database. Then we need machine learning engineer to build a best fit model to predict the number of homeless people in New York. And lastly, we need data scientists to make a hypothesis testing to decide which predictors are the most significant to homelessness. We designed this project by using Business Model Canvas or BMC. We would like to highlight 3 important keys on this BMC. First is our value proposition. Our main value is to prevent vulnerable citizens to become homeless and also help government to predict the number of temporary housing needed for those vulnerable citizens. The second important key is our customer segments. We are making a non-profit project, so our customers are mainly for the homeless people in New York City, and also helping government make their decisions combating homelessness. The third important key is our key activities. First, we identify the problem in the real world. Then we collect the data by the data engineer. And then we do cleaning, wrangling, and visualizing the data, usually by data scientists and or machine learning engineer. And then we create a machine learning model by machine learning engineer. And lastly, we create a hypothesis testing to finally determine which factors are significant to homelessness.
For the challenges, we found that there are many sources that have temporal data and with different rate of intervals and with different rates of time. Thus, it can lead to the issue of velocity on big data. We can overcome this problem by using interpolation and averaging two predictors to match the interval of the target. And then, the data that the homeless people that are being collected can be the citizen of another state, thus making the data less accurate. This is an issue of data veracity that we can overcome by making coordination with the official government to ensure the reliability of the data. And then, the data that has been collected can be insufficient for machine learning to be able to analyze, and this can lead to the quality of confidence on the result. And this is the volume issue. To compensate for this, we can make a less complex model to match the size of the data. And lastly, we can see that the data mainly comes from the government bodies. Thus, it can lead to biased results and lack of data neutrality. And this is a variety issue of big data. We can propose for transparency on where the data are collected and how are we processing it. And next, for the asset for the architecture design, we use for this data science project, it consists of 6 keys, starting with the data source. We use New York City Open Data that has the data source of homeless people in New York City. And also we use other government website data. And for data ingest, we use Cassandra Apache to ingest data from multiple data sources that can be in the form of unstructured like JSON or structured like CSV or SLSX. And the data will be stored in the form of JSON file because it is low on maintenance and it is open source. And for data analysis, the cleaning, wrangling, or exploratory will be done in RStudio, and it will also be used to create the model that will be used for data visualization because it has an extensive line of library that will help us. And the visualization will come with RShiny that is compatible with RStudio that we can help to make sophisticated and interactive visual. And lastly, the implementation will be on Shiny that can help us to make an interactive visual for the user to use. And then for the data governance and management, we have three, which is confidentiality, data accessibility, and security. The first one is confidentiality. For the personal data of the user, you cannot take it without their consent because they can lead to sue us if we use it without their consent first. And the combination of data source can, if user can know, they can detect other individual homeless using that combined data source from us. That's why we need to have the data retention policies to delete the user that aren't homeless anymore. And for the data accessibility, it need to be accessible for the public for our combined data set. And also we need to be transparent on how we use the data and how we process it. And lastly, for the security, we need to have a backup for the data we use. So if something happen in the future, we have a backup to be able to use it again.
My name is Iwan Darmawan and I will present about data analysis process where we use multiple linear regression to understand the contributing factors behind homelessness. Why we use multiple linear regression? Because it's a powerful tool that helps us to understand relationship between variables. In our case, we want to see which factors most influence homeless number. These techniques were chosen due to the ease and low cost of implementation. Our first data analysis is data collection and wrangling. We gather data on various potential predictors like domestic violence, household income, number of employment, and so on and so forth. Then we wrangling the data because it comes from various sources. So we have to tidying up the data and merge it into one merged data. The next step is model building. After proper processing and cleaning our data, we fed it into our multiple linear regression model. This allows us to quantify the relationship between each predictor and homelessness. The key findings of this project is that this model can highlight the specific features that contributed to the homeless numbers with a very good number of p-value. But this become a problem of overfitting model. This model result on test data becomes so poor. So we still need to evaluate the process of modeling to find the better model that can predict the homeless. This is the product example of what our project will look like. It is an interactive dashboard using AirSign application. Why we use AirSign application is that it shows sophisticated visualization and give interactivity to the user. User can adjust the parameters they want to include or not, and the visual will be reactive to the user's input, showing the model's output. The visual analytics can also highlight the most important feature affecting the number of homeless. The next part is project benefit. What are the benefits of this project? The first one is data-driven decision making. It allows us to make informed decisions about homelessness. With predictive analytics, the government can forecast potential homelessness hotspots and prioritize affordable housing in those areas. Our models can also identify population at the higher risk, enabling timely intervention to prevent homelessness. This project also ensures the budget of the city can be allocated effectively to address homelessness problem. The second benefit is adaptability. This model can be adapted to other regions or city. But while AI models can be standardized, it's crucial to account for unique factors like culture, environment, or socioeconomics. The third benefit is collaboration with housing providers. It takes form of partnership to the private sector, and it allows mutual relationship where they can exchange valuable information. The last benefit is beneficial in urban design. City planners can design with a vision to minimize homelessness and design shelters and public space to the needs of the homeless with supportive environments. In conclusion, this project provides a holistic approach to tackling homelessness in New York City, combining data science and others area collaboration, and together we can create a city that's not only smart but also compassionate. Thank you.